of a liquid using determination of density of a liquid using weighted test tube. Weighted test tube. Using weighted test tube. Okay, the respective theory part is this. Look at here. Respective theory is law of flotation actually. Law of flotation. Look at here. Now, if a test tube floats, if a test tube floats in a liquid like this, if a test tube floats in a liquid like this, right? Let's say total mass of this tube is mg, right? And from water we know upthrust acts here, right? So by law of flotation we know, by law of flotation we know this is in a vertical equilibrium. So therefore, what law of flotation suggests is u equals mg when an object floats, right? There are 2 points satisfied by law of flotation. Upthrust equals weight and center of buoyancy and center of gravity are on the same vertical line, right? Now, using law of flotation, see, by law of flotation, vertically upwards forces equals vertical downward forces. Vertically upwards, that is only u. Vertical downwards, mg, right? And u can be expanded. Sorry, u can be expanded as v rho g, right? So which means if this immersed volume is v, if the immersed volume is v, this can be written as v rho g equals mg, right? This is the associated theory part here, the respective theory part here. Now let's see how this is going to use in the calculation, in the experiment and the determination. Okay, as a theory, take it down. As a theory, take it down first. Take it down as the theory. Law of flotation. It comes from law of flotation. Finished. Stay vigilant until the last one. Now, after today, you don't have anything to know about these 5 practicals we discussed, right? Refer these things again and again. And I have mentioned the past paper questions that have been already come. So you can try questions and see how the questions are asked, right? How all theories are covered. And if I got a free time later on, I'll be conducting a discussion on the past paper questions on these experiments as well. But during these 2 months, it's not that sure. The thing is, with the 25 classes, I'm a little bit busy these days, right? Because now for 25 students, this is the 9th week ongoing. They have just 8 weeks remaining for the exam. Just 8, right? Just 8 weeks before the exam. Registrations. Oh, sorry, I forgot to mention actually. Yeah, about the registrations, what you can do is, one thing is, now my website is working. You can go to this website, psphysics.lk, and you can create an account and register the class, enroll to the class there, or else for any other inquiries you can contact that number. I mean, my number, contact through my number or the hotline number here in Mashma Institute if you are joining to Mashma. If you are an online student, you can just go there and get register yourself. Right. Okay, look at here. Now, this is how the setup is going to be used. See, look at here. Now, final target here is determination of density of a liquid. Then, which means density of that liquid is unknown. That is why we are going to determine. Right? So, therefore, we are not going to consider water like a liquid here because that is anyway a known liquid. We don't consider water. See, now we have to have a tall jar like this. A tall jar. Look at the board. Don't write, just look at the board. A tall jar. And the test tube. Where a test tube? The test tube. This is the test tube. Right? And here we do something like this. This curved part of the test tube is filled with either iron balls or, now I explained you two things we need: a tall jar. One is a tall jar, right? And then we need a test tube. We need a test tube. And now here we have a curved part for any test tube. No? This part is the curved part. Look at the board. There's a nice idea here, right? This curved part, we are filling it with either iron balls or lead shots. Lead shots. Have you seen iron balls? Iron balls? Bicycles එහෙම තියෙන්නේ. Bicycles එහෙම දන්නා පොඩි කාලේ. පොඩි කාලේ bicycles වල එහෙම ගලේවම දැකලා නැද්ද මේ iron balls තියෙනවා handle එක වටේ. They are called iron balls. Anyone? Haven't seen iron balls? See, Viroji, why taking for you? U equals Viroji. Upthrust. Haven't you seen iron balls? Oh, okay. There is something called iron balls. Very small balls. Pebbles, like pebbles. That is made of iron. That is called iron balls. Right? What we do is, we are filling, look at here, we are filling this thing, this part with iron balls. This curved part with iron balls. Look at here. Filling this curved part with iron balls, and wax is used to seal this area, and we are using wax, melt wax to seal this area like this. Iron balls dala meka seal karala dana. Got it? It is filled with iron balls and then sealed with wax. Right? Now, from here onwards, here we have a scale. We are pasting a scale. Scale like on the glass tube. On the glass tube. Now, after this point, now this vertical part starts. All curved part is covered with the wax now. Right? And this scale is only for the linear part of the tube. Right? Calibration is only for the linear part of the tube. Right? Then, now we have a liquid to determine density. That liquid will be filled to this tall jar like this. And now this is filled with that liquid. Let's say density of that liquid is rho. Density of that liquid is rho. Right? Now, using this scale, we can measure this height easily when we need. Let's say L. Right? Once we need to measure this height, easily we can measure it using the scale here. We have pasted the scale. Right? Otherwise, now when this tube is floating, when the test tube is floating inside jar, you can't insert any meter rulers or half meter rulers into that and do it. That is not practical, because when the meter ruler hits with the test tube, this equilibrium will be like it's waving. Equilibrium is breaking, harming. We are harming the equilibrium. So therefore, we have pasted the scale there. No questions. Right. And let's consider area of this tube as area, cross-sectional area of the tube as A. Right? Okay. Cross-sectional area of the tube as A. Right. Now, let's first mention the materials. Next heading, write down materials and apparatus. Next heading, materials and apparatus. Materials and apparatus. Materials and apparatus. Okay. Subheading, materials. Subheading, materials. So will it be floating without turbulence? Yes. That's law of flotation. And when this is heavier, now with iron shots, with lead shots and iron balls, now this part is made heavier. So therefore it floats. It's stable. Right? Materials, mention one by one. First one, a tall jar. A tall jar. A tall jar. Next one, a test tube. A test tube. A test tube. Then iron balls or lead shots. 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 Right? Then a small quantity of wax. A small quantity of wax. A small quantity of wax. And next, few mass units. Few mass units. I'll explain why we are using mass units. Write down first. Few mass units. Few mass units. Next one, last one, a liquid of which density should be determined. 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 Okay. Look at the board. Look at the board. Right. See, now this empty test tube with lead shots or with iron balls, this whole thing has a mass, no? So let's consider that as capital M. Right? Let's consider that as capital M. Then mass of this part is mass of this part, capital M. I'll mention here, capital M. Mass of test tube with iron balls. Mass of test tube with iron balls, capital M. And now we are using some additional masses here to load onto this tube. Loading means now using a small string, we are loading masses into the test tube like this. Additional masses, right? Once an additional mass is put, simple name, let's say additional masses. Right? Once a mass is put, since mg increases, see, according to the equation, since mg increases, since weight increases, this goes down further. This immerses down further. right? Which means now we are changing m, we are changing mass of the system. Changing variable is going to be the independent variable, and accordingly immersed height is going to be changed. Immersed height is going to be changed. Then L is going to be dependent variable. L is going to be the dependent variable, right? Now considering that, we are going to apply this theory again, apply law of flotation again, right? Now there are two masses, capital M here and simple M here. Then altogether total mass of the system is M plus mg, no? That's clear. Total mass of the system, right? And upthrust acts on the system, let's consider the upthrust as U. I'll consider the upthrust acts on the system as U. We'll mark somewhere here. Upthrust act on the system as U. Upthrust act on the system as U. Right? Okay. Look at the board. Now, according to law of flotation, vertically upwards forces equals vertically downwards forces. Right? Vertically upwards, U again, and downwards, now 2m's, m plus m, g. Right? We know upthrust can be expanded as V rho g. Upthrust can be expanded as V rho g. Right? And V is the immersed volume. Where V is, if anyone don't know these meanings, if you are in 26 batch, there is no way that you don't know these things. This is called immersed volume. Immersed volume. Immersed part. Immersed volume. Right? Now immersed volume is the volume of the curved part plus the volume of this cylindrical part. No, now this is a tube. There's a curved part. There's a curved part at the bottom like this, and here is a cylindrical part, right? So the total volume is the curved part's volume plus the cylindrical part's volume, right? So I'll assume volume of the curved part as V. Volume of curved part. I'll assume volume of curved part as V. Now, if volume of curved part is V, we can write this volume. I can expand this volume. See, this is V total. Total volume into rho G equals M plus M G. G to G cancels. Total volume consists of volume of the curved part plus volume here. And we know if there is a uniform cross-sectional area, volume can be written as cross-sectional area times length. That's a normal thing. Volume can be written as cross-sectional area times length. Okay. Then this total volume is V of curved path plus V of cylindrical part. V of cylindrical part. Rho equals M plus M. Right? V of curved path is already considered as V. Right? Look at here, very important. V plus V of cylindrical part can be written as AL. If cross-sectional area is A, that is AL. Rho equals M plus M. Now, what is the changing variable here? Independent variable? Independent variable is simple M. Simple M. And with that, the dependent variable is L. L is here. Now, here onwards, the target is subject in L. Target is to subject L. Because L is the dependent variable. L is the dependent variable. Subject L. Now, hereafter, this is just a matter of subjecting this. See, subject L. Now, V plus AL equals M plus M over rho. Right? And AL equals M plus M over rho minus V. I'll do the rest here. Right. Then subject L by dividing the entire equation with A. Right. So L equals M plus M over rho A minus V over A. Right. Now we can divide these two terms separately. M over rho A plus simple M over rho A minus V over A. Now since this is my independent variable, now I'm going to separate this independent variable. See, L equals, take it somewhere here, 1 over rho A times M plus this part is M over rho A minus V over A. Okay, now we have taken this equation to one of the standard forms. This is my X, and whatever it is as a multiplier product with X is gradient, and this entire part added here is C, intercept. This is Y. So finally the equation has become Y equals mx plus C. If there is an equation of Y equals mx plus C, we can plot a graph by changing M values again to 6 instances. Now we have, I mentioned, we have few mass units. So by adding 1 by 1 mass units, we are taking 6 readings again. If 6 readings are taken, we can plot the graph between, I'll plot the graph after erasing this. We can plot the graph between, shall we draw here? We can plot the graph between simple mn, L. Right? Then accordingly, you have few points and a graph mx plus C. You have few points with a graph like this. Right? Okay. So let's see how this is determined using the graph. Now that is the idea. By adding masses 1 by 1, mass can be changed. If mass is changing, independent variable will be mass, and then accordingly L changes. When L changes, there is a dependent variable. So we can plot the graph between M and L. Right? So always in experiments, we are always trying to plot graphs somehow, because that is how accuracy can be increased. When we plot a graph, accuracy is increased. Otherwise, if we just use an equation for a given instance and do something, there is only one instance of less inaccuracy. But here now we have dealt with 6 instances plus dealing with a straight line, a graph. By considering 6 points, we are plotting a graph. Right? 6 points are bias. There's no bias points there, because we are plotting the graph as it is unbiased for all 6 points. Right? Okay, where did we stop? Only materials. Okay. Then apparatus. Next heading, apparatus. Write down next heading, apparatus. Next heading, apparatus. Write down the heading, apparatus. Now I think it's clear. It's clear to you that compared to first 3 experiments we had, last 2 experiments are kind of advanced. That's why I told you. When it comes to questions also, questions from these 2 are very popularly coming. Right? These 2 are a little bit advanced compared to first 3. First 3 were very easy. Right? Apparatus. Take this down. Take down the apparatus. Take down the apparatus. Take down the apparatus. This part. Huh? Don't write the method. Apparatus. Take down the apparatus. Just the apparatus. Don't write the method. And if iron balls are not available, as a substitution, we can fill this with sand. That is also possible. Huh? Iron balls නැත්තම් මේක කරන්න නැතුව ඉන්න ඕනේ නැහැ. sand දාලා ඒක කරගන්න පුළුවන්. No, because this is heavier now. This side is heavier, so therefore it's stable. Right? Otherwise, if this is not filled with iron balls, that is toppling. That's toppled. That is not stable. Now, once we filled it with iron balls, this bottom is heavier now. So it's stable. It's stable. That is why iron balls or lead shots are used. So we can take V as height. No, V again volume. So y is object L. L is the dependent variable. Before y equals mx. Subject L. Subject L. So for materials, one meter ruler come under. So for materials, one meter ruler come under practical number 5. No. First four practicals are vernier caliper, micrometer screw gauge, spirometer, traveling microscope. It's even hard to understand. That is because you are from 27 batch, right? Otherwise, low flotation and these things we have covered in theory classes, right? That's what I told you now. Compared to first three experiments, these last two are a little bit advanced. There are something to think of. There are something to think of, right? Now, knowing theories is a basic thing, right? I told you at the beginning, knowing theory is a basic. Now, anyway, I recalled you the theory because to anyone to recall the theories, even if you have done or if you haven't done, just to recall. Okay, finished? Right. Mention these three. Capital M, test tube with iron balls. Mention these three. Simple M, additional mass. V, volume of curved part. Mention these three as well. Mention these three terminology. These three terminology. Mention these three terminology. Mention it. Right? Okay, under apparatus, write down first point. First point. First point, fill test tube with iron balls. Fill test tube with iron balls. Fill test tube with iron balls. No, under apparatus. Under apparatus. Point 1. Under apparatus. Point 1. Fill test tube with iron balls. Fill test tube with iron balls and seal it using wax. And seal it using wax. Seal it using wax. And seal it using wax. Next point. Next point. Paste a millimeter scale. Paste a millimeter scale. Paste a millimeter scale. Paste a millimeter scale on test tube. Paste a millimeter scale on test tube. Paste a millimeter scale on test tube. Right? Okay, then method. Next heading, method. 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 Right. Now start from here and take down up until the graph. Right? මෙතනින් පස්සේ line එක මෙතන තියෙන්නේ. Right? Starting from here, take down up until the graph here. And when you have space below this, you can plot this graph below y equals mx plus c. Right? So below y equals mx plus c. Right. Take it down. Take it down. Send me your questions if there's anything. Now we are in the last experiment. Last experiment in mechanics. Last experiment in mechanics. And I'm repeating again. Now you can see the impact of graphing knowledge when it comes to experiments, right? So this is everything based on graphs, graphing. So therefore, if you don't know graphs, now it's, if you are 26, that is too late, right? So therefore, the video of the previous class I had on graph plotting is still on the channel. So please go there and watch it and make yourself comfortable with graph plotting. That is an essential skill you have to have when you are going to the exam, right? Now, if you are not familiar with these graph shapes, identifying variables like this, mx plus c, y, so those things, if you are not familiar, right? Go and watch that video and make yourself comfortable. That's a must. That's a must. Finished? Here. V total. Here. V curved plus V cylindrical. Right? Listen all. Here this is V total. Total volume. V total. This is V curved. V curved क्या मे part है? V curved plus V cylindrical. Cylindrical क्या मे part है? Because the test tube consists of one curved part and a cylindrical part. Right? And total volume can be written as the addition of these two. Why is wax used? To seal iron balls. To seal iron balls. Otherwise, there will be voids remaining inside iron. Voids, empty areas. Void remains. So therefore, to seal it, wax is used. Then wax is going into those voids and it will be sealed without having any air bubbles inside. Air bubbles video make a varadino. There will be errors in the experiment if there are air bubbles inside. Right? So it should be completely covered, sealed using wax. Wax use karanga. Wax melt kala danna, you know, when wax is heated, it gets melted. So then it can be poured onto the tube and sealed. Poured into the test tube and sealed. Right? Finished? Okay. Then write down first point under method. First point, write down. At weight units, one by one, at weight units, one by one, into the test tube, slowly, with the help of string, Next point, take 6 readings. For L. Take 6 readings for L. For 6 instances. Right? Next point. Plot the graph between Plot the graph between M and L. 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 Okay, now plot the graph. Plot this graph there. Plot this graph. Plot this graph and mention gradient like this. Gradient. Let's say M. Now from this you can see gradient of graph is, right? Gradient of graph. Simple M is, see, this is the gradient. This is the gradient of graph. 1 over rho A. Gradient of graph is 1 over rho A. Right? Now we are determining density of the liquid. Rho should be determined. Subject rho. So rho is 1 over M times A. M is gradient. M is gradient. M is gradient. Gradient. Gradient times A. Now, in order to determine density of the liquid, we are lacking another data. What is it? Rho is 1 over Ma. We need A. We need cross-sectional area of the tube now. That's the idea. We need cross-sectional area of the tube now. Which means cross-sectional area of the tube should be measured. It should be measured. How we can determine cross-sectional area of a tube? Tell me, using measuring instruments. Simply using a vernier caliper we can do. External jaws of vernier caliper. Using external jaws of vernier caliper, you can get the external diameter. If external diameter is known, then cross-sectional area can be determined. Right? That is what we need to do. Now, using a vernier caliper, you have to find the external diameter of the tube now. External diameter of the tube. Right? Using the vernier caliper, find the external diameter of tube. This one. So let's assume that external diameter as D. If the external diameter is D, I'm going to erase this part. Look at the board. If the external diameter is D, look at here. If the external diameter is D, external diameter of test tube. If there is D, we know area is pi r squared. No? Area of a test tube is phi r squared. So this can be written as phi r should be d over 2 squared. Right? So that is phi d squared over 4. Right? So we can plug that value here. You can plug that value here. So rho is given by 1 over ma, but a is phi d squared over 4. Simplify this. Simplified value is 4 over phi md squared. Now, m is gradient. So repeating again, m is not a mass, m is gradient. Right? If there is like not clear, you can make this m dash. I don't mind. M dash, right? Gradient m dash. M dash, m dash, m dash. Now, m dash is known, gradient is known, d, diameter is known, phi is a known value, that's a constant, rho is a constant, then a calculation can be done and rho can be determined. That is the end of the experiment. Right? So there are a few things to be understood. Okay, now after taking down the graph, mention everything up to this point, and with that note, mention this thing also. Right? Mention this thing also. Can see? Exam. Finished. Right? That is the end. To measure this, we need a vernier caliper. To measure this, we need a vernier caliper. So in the materials, mention vernier caliper. In the materials, add vernier caliper to the material list. Vernier caliper. Right? So you can use external jaws of the vernier caliper and measure this and find A. To find A. Okay. Right? Understood? So that's it for the experiment. And as the last heading write down, remarks / important points. Remarks / important points. Remarks / important points. Remarks / important points. First one, remarks. Remarks. Remarks / important points. First one, iron balls should be filled into test tube. 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 Filled into test tube. To make it stable, when floats. To make it stable when floats. Right. Next point. Second point. Entire curved part of test tube should be filled. Entire curved part. Entire curved part. Entire curved part of test tube. Entire curved part of test tube should be filled. Entire curved part of test tube should be filled with wax. With wax. Entire curved part of test tube should be filled with wax. Right. Okay. So that is the end of the 5th practical. Right. Any questions? Any questions? Anything to clarify? Now today, starting from the morning, now we have discussed all 5 experiments we have in mechanics. Right? Any questions? So we have discussed all 5 experiments